Hello viewers, welcome to my tutorial again. So I'm here to tackle this question, simultaneous equation. So if you are new here, please help me to subscribe, and if you've subscribed already, help me to like and share to your friends. So how do we solve this question? We have so many methods we can use to solve simultaneous equation, but what I want to use now is I want to use a trick, a situation whereby we find this question in our examination and it's objective. We can easily apply short method, which we can just get the answer direct. That is what I want to do. Watch out and see the way I will do it. So here we are taking this. I will use the coefficients of this here, which is 2, the coefficients of y, to multiply this constant term. Then I will use the coefficients of 3 here to multiply this constant term. After that, I will now take this again. That is, I will use the coefficients here to multiply this. I will use the coefficients of this to multiply this. Then after that, I will now take the whole equation, everything here. I will use this to multiply this. I will use this to multiply this. Let's see how it works. So firstly, my x will be equal to, so you use this to multiply this. 8 times 2, we are going to have 16 minus, then 3 times 7, we are going to have 21 all over. Then you come to the second one. So 2 times 2 will give us 4 minus 3 times 3 here will give us 9. The answer will now be minus 5 over minus 5. So this will cancel to give us a 1. That is the value of x. To get the value of y, I will now use the entire bracket here. That is, I'm using 2 to multiply this, then this to multiply this. 2 times 7 will give us 14 minus 3 times 8 will give us 24 all over. So I'm using the second bracket as well. That would be the general value to divide the value of x and the value of y. So I will also have a 4 minus 9, and this will give us a minus 10 over minus 5, and the answer will be what? Will be 2. So x and y will now be 1 and 2. So this is the solution for this system of equation. But the question is, how come about this method? It's not hard. This method is the method we know before, which is crammer's rule method. So I derived this logic, or we use logic of this to solve from the crammer's rule, the general crammer's rule we know. And we know from crammer's rule that if you have a system of linear equation of a1x plus b1y equal to c1 equation 1, and you have a2x plus b2y equal to c2 equation 2. So this is a system of linear equation of two variables, that is x and y. So we can easily change this to matrix form. So we have a1, a2, b1, b2 into x and y equal to c1 and c2. So a1 and a2 are the coefficients of variable x, b1 and b2 are the coefficients of variable y, while c1 and c2 they are the constant terms for equation 1 and equation 2 respectively. X and y are the variables which we want to find their values. So you agree with me, with the knowledge of the matrix which we've discussed, if you are here and you don't know we've treated the determinants, you can easily check the description box so that you see those videos which we treated under these matrices. So with the knowledge of our matrix, we can find the general determinant. Let the general determinant of this system of equation be this. So which is a1, a2, b1, b2. So when you solve this, find the determinant is going to be this and this, then this and this. So you have a1 and b2. This and this minus a2 and b1. So that will be the determinant and the general determinant. So to find the determinant of x, we have to replace all the coefficients, the values here, which is the coefficients of variable x in equation 1 and equation 2. We replace it by this constant term. We are going to have a C1 and C2. So the coefficients of y will still remain, which is B1 and B2. We find the determinant as well, this and this. So this time this will give you C1 and B2 minus this time this will give you C2 and B1. So we find the determinant of y as well. To find the determinant of y, the coefficients of x will remain as A1, A2. The coefficients of the coefficients of y in equation 1 and 2 will also be replaced by this constant term. We are going to have a C1 and C2. So when you find the determinant as well, this time this will give us A1, C2 minus this time this as well will give us A2, C1. So to get the value of x and y now, our x will be equal to determinant of x over general determinant. And to get determinant of y, or to get the value of y, we have determinant of y over general determinant. What is determinant of x? This is the determinant of x, C1, B2 minus C2, B1, all over general determinant. This is general determinant, which is A1, B2 minus A2, B1. So here, to find this, the determinant of y is A1, C2 minus A2, C1, all over general determinant, which is A1, B2 minus A2, B1. So this is the logic that I used to solve this system of linear equation. So you agree with me that if you label this to be A1, A2, B1, B2, C1, C2. So our x directly will just be, according to what I derived here, our x will be B2 times C1. You can see it from the equation, minus C2 or B2 times C2. That is what I have there. So all over the determinant, which is general determinant, A1 times B1 and B1 times A2 or A2 times B1, which is our general determinant. Then for the determinant of for the y, we have A1 times C2 all over A2 minus A2 times C1. So that is what you have divided by the general determinant. So this method is Crammer's rule method of solving system of linear equation. So you can only use this method when you are dealing with system of linear equation. But a situation whereby you are dealing with one linear, one quadratic, you cannot apply Crammer's rule. So we apply other methods. So this is what I have for you today. So if you are new here, like I said, please help me to subscribe, and you can help me to share to your friends, likes and comments. You can also drop questions to my page, please. So tomorrow we are going to look another thing again. Thanks so much.